Hello everyone and welcome to my video on factoring quadratics, special cases, perfect square trinomials. There was also a video of special cases different to two squares, so if that's what you're looking for, that's on a different video. Alright, so perfect square trinomials. They're called perfect square trinomials because they're a trinomial that comes from a perfect square, which means it comes from a binomial squared. And so we took a binomial like a plus b and we squared it, or you can also take a minus b and square that. All right, so if we were to square that, we would get a squared plus 2ab plus b squared, or a squared minus 2ab plus b squared. Now, the whole point of learning this is to kind of save some time when factoring if it is a perfect square trinomial. So if you see this down here being able to go up here in less effort than if you were actually going to factor it the long way. Now, in order to be able to do that, you need to recognize when it's a perfect square trinomial, because you're not going to see the binomial square. That's going to be where you're getting to. Right? You're going to have it in the opposite order. Right? You're going to see up top, and you're trying to get down below. So the pattern that you look for is really three things you're looking for. The first term needs to be a perfect square. The second term needs to be plus a perfect square, right? That cannot be minus, so it has to be plus a perfect square. And the middle term can be plus or minus, but it needs to be double the product of the square roots of the first two terms, right? So that could be a little confusing, and it needs to be double the square roots of the products of the first two terms. So what I do is I really only look for the blue and the red. I look for the perfect squares in the front and the left. I'm sorry, the left and the right, front and the back. And what I do once I see their perfect squares is then I test it. Does the middle term meet that condition? So what I would do is see the perfect squares, maybe even create the binomial, and then I would say, okay, what's a times b times 2? Right? And then I times it by 2, and does that get me to that middle term? And if it does, then I know I have a perfect square trinomial. So let's go ahead and try some actual examples, and it might make a little more sense for you. Right? But this is just the generic structure of that. So I'm just going to grab this example that I had already prepared, and we'll take a look. All right, so to go through the steps, the first thing I do, I check, is the first term a perfect square? Yes, x squared is a perfect square. Is the last term plus? It is. And is it a perfect square? Yes. The square root of 25 is 5. So then I'll go ahead and I'll say, okay, the square root of x squared is x. The square root of 25 is 5. And I might even go out of my way to create this binomial. And you're going to get the square root of the first term and then the square root of the last term. And what you're going to do is you're going to take that first sign, and whatever that first sign is, that's going to be what you put in your binomial. So since it's a minus, that's going to be what goes there. All right, and then once I have this done, I just double check to make sure it is a perfect square trinomial. So I'll take x times 5 times 2 and see if that's 10x. So x times 5 is 5x, times 2 is 10x. So yes, this is a perfect square trinomial. And I'm done factoring it, x minus 5 squared. All right, so let's take a look at another example. Okay. And finding that middle term is probably what the hardest part of this is. That's why I kind of do it as a check afterwards, because you might miss some if you're looking for all three conditions at the same time. So what I'll do is, again, I'll go through and I'll sit here and I'll say, okay, is the first term a perfect square? Yes. Again, this is usually easy to recognize, and it's usually easy to recognize the last one's a perfect square. Again, the last one has to be plus or this doesn't work. So then once I recognize that they're perfect squares, I'm not really worried about the middle till I kind of start setting this up. I know the square root of 9x squared is 3x. The square root of 9 is 3, and the square root of x squared is x. And the square root of 49 is 7. I don't have to worry about signs because I already know that one's a plus. And I'll worry about the sign in binomial in my last step here. So I set up my binomial. It's going to be a binomial squared. The first term is the square root of the first term. The second term is the square root of the constant or the last term. And then for the sign, you're going to look at the first sign and you're going to bring that down into your binomial here. Okay. Now I just want to double check that this is a perfect square trinomial. So I multiply the a and the b. So 3x times 7 is 21x, and then double it. Double 21 is 42. So 21x times 2 is 42x. So I have it. This is a perfect square trinomial, and my answer is a binomial squared, 3x plus 7 squared.